Hi everyone. This is my Paisabazaar data science project video. I'm going to discuss my project here. So let us just see the problem statement and little bit information about the project. So this is the description of the problem statement. So we have the data set of some customers, including the columns like payment behavior, age, name, SSN, and credit scores. So we have to analyze the state data, and we have to make a machine learning model to predict the credit score based on several features like payment behavior, depth, and etc. So let's just move to my Jupyter notebook where I have completed this project. So this is the data set of Paisabazaar. So there are some columns in here like age, SSN, occupation, annual income, monthly in hand salary, number of bank accounts, credit mix, outstanding debt, history, payment of minimum accounts, and these with the help of these columns, we have to predict the credit score. We have to analyze these columns, and we have to understand the relationships of these columns with this target column, that is credit score. So first of all, I have imported all the libraries here: NumPy, Pandas, Seaborn, and Matplotlib. I have loaded my data set with the help of Pandas, and this is some little bit. I have just modified the columns so that I don't face any error. So this is the information of my data set of all the columns like ID, customer, month, like the data type of ID is int. There are some of the columns are of object data type. So starting with EDA, Exploratory Data Analysis. So this thing is done because this is the main thing before machine learning model building, and whether we build supervised models or unsupervised models, this is the most common step that we have to do. EDA. In this we process the data, we clean the data, we modify the data types, and we make some changes like we can add some more columns to improve the efficiency of our predictive analysis. We can do so many things. So all the things before feeding a data into a machine learning algorithm, this step is done. This is EDA. So first of all, we will check the null values, that how many null values does our data set contains. So this is the command data dot is null dot sum. So we can see there are no null values. So if our data set had some null value, so what we can do is we can directly drop null values, or we can replace them. And secondly, we will check duplicates. So there are also no duplicates in this data. And if there are so many duplicates, and so we can replace them by a mean or mode. If the data type is integer, we can replace that column with the mean, and if the data type is object, we can replace the data with mode. So next thing, we will check the outliers in this data types, in this data set. So to check the outlier, we have to first see that if the data, if that column is numerical or not, because of the object data type, we cannot see the outliers. So I'm just running a loop, and I'm just checking if the data type of that column is object or not. If it's not object, that means it's numerical, and we can plot the box plot, and we can see the outliers. So there are some columns, we can see the outliers. So like in this column, it contains some outliers in this range from here to here. So the annual income in monthly enhanced salary column also contains some outliers, but we have to make sure that if we are dropping the outliers, it does not impact very much in our data set, so that it can affect our model building and our predictive analysis. So these are with the help of this, we can see the outliers, and we can make a list of columns of outliers, and we can eliminate them. So nextly, I have declared a function to detect the outliers, and so annual income outliers. I am just passing the detect outliers function, data set, and the name of the column. So it will return me the outliers. Similarly, for monthly salary, I have done the same thing. I've used the detect outliers function to check how many outliers are there in monthly salary column. And similar for delay due date column, outstanding debt. And after that, I have just collected all the names of outliers in the Python list, and I have just gone through each column, and I have eliminated them. So we can see the remaining rows are 89,000 in this. So after that, we will use some charts to make some conclusions in a data set. So the first is I'm plotting the count plot with credit score. And so with the help of this chart, we can easily see that maximum number of customers are in the category of standard credit score. And after that, they are in the category of poor credit score. And very few, minimum number of customers are in the category of good credit score. And so nextly, we can analyze the numerical columns with the help of a box plot. We can easily see the outliers of various numerical columns like age, annual income, and monthly in hand salary. So this is the step to easily figure out the outliers of each column, that how many customers are in depth, or they have some odd one out range. After that, we have I have gathered all the categorical columns of this data set, and each categorical column I'm plotting a count plot to see how many credit score are how many good, standard, and poor credit score are there in each category. So like this, for occupation versus credit score, we can see the maximum number of standard credit score customers are from the lower occupation range. So like we can see from the scientist, this or the orange or the orange chart means this is a good credit score. Blue color is for good credit score, and the green color is for poor credit score. So we can see how many good, standard, and poor credit score of each occupation customers. Nextly, we can see the credit mix versus credit score. We can see maximum number of standard credit score are of standard credit mix, and the max amount of good credit score customers are from the good credit mix. After that, the payment behavior column versus credit score, we can easily see the max amount of standard credit score customers are in the category of low spend medium value payments, and after that uh, low spend small value payments. We can easily see the category of all the types of payments and the credit score customers. Similarly, for payment of minimum amount and after that, this is the pair plot of numerical columns and credit score to see the relationship between the columns and the credit score. We can easily see. So after this, I have used a scatter plot between outstanding debt and annual income to understand the credit score. So we can clearly see these orange balls. There are so many orange balls till the range of from the range of 0 to 1500. There are so many orange balls. So these orange balls are standard credit score customers. The blue balls are good score customers. So we can easily identify the ranges where max amount of standard credit score customers, and after that we can easily see as the outstanding debt is increasing, the number of poor credit score customers are also increasing. So we can easily identify uh, the relationship of outstanding debt and annual income, how it affects the decision of credit score of customers. So this is the final summary of of the above charts that I have prepared. So the majority of customers have a standard credit score, while the number of customers with a good credit score is the lowest. So we have already seen that the maximum amount of customers are with standard credit score, and the occupation versus credit score. Almost all the professions, the distribution of good credit score customers is relatively even, as observed from the count plot. Most of the standard credit score customers are lawyers, and the difference across profession is not that substantial. Overall, the standard credit score are fairly evenly spread among different occupations. After that, we have credit mix versus credit score. Customers with good credit mix tend to have the highest number of good credit scores. Similarly, customers with standard credit mix have the highest number of standard credit scores. After that, the payment behavior versus credit score. The majority of standard credit scores customers fall in the categories of low spend medium value and low spend small value payments. After that, payment of minimum amount versus credit score. Most good credit score customers do not make minimum payments. From the chart we can easily see. Whereas the large number of standard credit score customers belong to the minimum amount payment category. As after that, we have the scatter plot analysis between outstanding debt versus annual income. So very few customers with good credit scores have outstanding debt in the range of 0 to 1500. We have already discussed that in that scatter plot graph. The majority of customers with standard credit scores also fall within the range of 0 to 1500 debt range. As outstanding debt increases beyond 1500, annual income remains less than 80,000. The number of standard credit score customers decreases while the number of poor credit score customers increases. We can easily see here as the debt is increasing, the number of poor customers are also increasing, but in the range of 80,000 annual income. When the customers have the income less than or equal to 80,000 and greater than 1500 outstanding debt, the customers are falling in the category of poor credit score. So the conclusion parts end here, and after that, I have uh, I have done some data pre-processing. I have done label encoding in the columns of object data type wherever the data columns of the type is object, I have just encoded that column with the help of label encoder to convert the object columns into numerical data. So here I'm splitting the data into two parts, x and y. So the y is nothing, just the target variable data, that is data of credit score, and x is all the data columns leaving the target column. So I am just included all the libraries of train test split. I have split the data into x train x test, y train y test, uh, and the size of test is 0.2, random state is 42. After that, I have imported my decision tree classifier, and I have trained my model from X train and Y train, and I have just predicted uh, the result with X test, and you can easily see the accuracy is 75%. And after checking the overfitting, we have tested the model with the X train, and we are testing the accuracy with Y train. So we can easily see the accuracy is 96.81 8960. Before this, the accuracy was coming 100%. That is overfitting, because most of the time the dysentery goes overfitting. That means it learns too much, and so that is not beneficial in our prediction analysis. So after trying some combinations, I identified these parameters that are crucial, that are much better, but it's not that helpful. Criteria is Gini, max depth is 25, and min samples is 1, and flatus is best. So after decision tree, uh, sorry. So here I have just tested from 20 to from 20 depth to 41 depth each, from to test the training accuracy and test accuracy of each decision tree. So as we can see, when the depth is 20, training accuracy is 91, test accuracy is 75. That is very much a gap between these two. That means the model is underfitting here. So this was the grid search that I performed to find out the parameters of this more decision tree classifier. So this was the grid search that I performed. This is the param grid and dictionary. Criteria is Gini entropy, splitter is pass random, and max depth I'm taking till 40. Minimum sample split and minimum samples of leaf. So these was the results of this grid search. After that, I have implemented a random forest classifier, and here also I have tested multiple parameters like an estimators of 200, then 250, and then 300. So after testing multiple combinations, I have figured out these parameters that are giving me the best accurate results. So as you can see, the accuracy score of y test is 82.89, that is near about 83%, and the testing score training score of the data is 92%. There is a little bit there is some gap between uh, the accuracy and the training data, but it's not that extreme. The our My random forest classifier is working fine. So the test accuracy of my random forest classifier is 82.8%, and training accuracy is around 92%. So uh, this was my project, and I'm still trying to figure out some other techniques for another folding techniques and another data compression techniques to increase this accuracy from 82.89 to 84 or 85% to make my model more accurate, to give more accurate predictions. Thanks.